Congratulations, Longhorns. We've made it to the end of the second 6 weeks. And this is the review for the 6 weeks test. And it includes problems from both the first test and the second test. So a lot of these problems should look very familiar to you. There's only one problem that we've added that's different or new that wasn't on the other two tests, and that is the problem for the rational function, problem number 2. All right, so let's take a look at this first problem. Identify the vertex for the graph of f of x equals 2x squared minus 6x plus 11. So the first thing we're going to do is we're going to use the little formula that we gave you, negative b over 2a, to find x. Okay, so what I've done is I have used this formula right here, which is part of the quadratic formula. I'm just going to use this to find my value for x. It's also the way we can find the axis of symmetry. Okay, so I've taken this formula, I'm plugging in negative 6 for b, and I'm plugging 2 for a, and I get negative 6 divided by 2 times 2. This equals positive 6 over 4, which equals 3 halves. So x equals 3 halves. So that's my x value of my vertex. It's also my axis of symmetry. All right, so then I'm going to take that value, 3 halves, and I'm going to plug it back into my function where the x is r, and I'm going to solve for y because I want to know what the y value is for my vertex. So I plug this 3 halves back into x, and I simplify this. I just put this in my calculator, and I got 13 halves. And so 13 halves is my y value for my vertex. And that's all you have to do to get the vertex. Okay, question 2, we are finding the domain of this rational function. So remember what I said in class, denominator, domain. We also need to make sure that we don't have any factors that cancel out. We want to make sure we don't have any holes. And I believe in this function we don't have any holes. The numerator is already factored, so there's nothing we can do there. So I'm going to factor the denominator. The denominator is going to give us the value for our domain. All right, so the two factors I'm going to use are x minus 7 and x plus 3. And the way I got these two factors was I looked for the numbers or the factors of 21 that, the factors that multiply to give me 21, those numbers that also add to give me a negative 4, because I want those two numbers to be able to add together to give me negative 4. So the two numbers I found that multiply to give me 21, that add to give me 4, are 7 and 3. And since my negative 4 in the middle here is negative, my 7, the larger number, needed to be the negative one, so that I make sure that when I add negative 7 plus 3, I get a negative 4. So these are my two factors. These are the factors that are going to determine my domain. Now there's some values here that x cannot be, because if x is 7, for example, 7 minus 7 is 0. That gives me a 0 in my denominator. And I can't have a 0 in my denominator because I cannot divide. This is a divide by sign. I cannot divide by 0. So anything that gives me a 0 in the denominator, x cannot be that in the domain. So right here, x cannot be 7. And here, x cannot be negative 3. So you just set these equal to 0 and solve for x. That's how we're getting those values. All right, so how would we write domain? It always starts with a parenthesis and a negative infinity. And then we're going to go as far as our first negative number, which is going to be negative 3. And then you can put a u if you want to in here. And then we're going to go from negative 3 to positive 7. So x can be anything in between those numbers. And then if I want to put in a u, I can, or I don't have to, doesn't matter. I'll put one in because everybody likes that. And then the last one is going to be 7 to infinity. And that's how we would write our domain. So basically what this means is that the value for x right here in the denominator can be any number up to -3. Cannot be -3, but it can be anything in between -3 and 7. That would be okay. But it cannot be 7. Cannot be 7, but it can be anything to infinity after 7. So x can be any real number except -3 and 7. All right, so for problem 3, we're just simplifying, and we're just going to FOIL this to simplify it. All right, so here we have FOILed this, and we did 5 times 3 is 15, and then we did 5 times 7i is 35i, then -4 times 3 is -12i, then -4 times a +7 is a -28i squared. Then I simplified it a little bit. I combined my two middle terms into one term. So 35i minus 12i is 23i. And then this -28i squared becomes just a +28. And remember, the reason why that happens is that this I squared right here, the value for this I squared is -1, because I squared equals -1. So this is -28 times a -1, which gives me a +28. And then the last step is to just add 15 and 28 to get 43. So my final answer is the real part of my complex number is 43, and the imaginary part is 23i. So 43 plus 23i is my final answer. Okay, question 4 says, find all complex zeros of the polynomial function f of x equals x squared minus 2x plus 5 using the quadratic formula. All right, so here's a quadratic formula. X is equal to -b plus or minus the square root, b squared minus 4ac all over 2a. Now I need to identify my a, my b, and my c. My a is 1. My b is -2. And my c is 5. So it's important to identify those numbers first to make sure that you're entering them correctly into the quadratic formula. Be careful that you don't switch a and b. B is going to go into the formula first. So let's go ahead and write that. Negative, and then parentheses. Inside here we're going to put our -2. Plus or minus the square root of b squared. Now I can't just put -2 and square it here. I have to put the -2 in parentheses. If you don't do that, you're going to get the wrong number, and then you're going to get it wrong. Minus 4 times a, and I go ahead and put these in parentheses too, just to be safe, times c, which is 5. All of that over 2 times a, which is just 2 times 1. Now I'm going to simplify this. A -2 is just a +2. Plus or minus, and now I want to find out what my discriminant is. What is the number that's underneath my radical? I want to calculate that separately because that number there is going to tell me whether I have 2 imaginary solutions, 1 real solution, or 2 real solutions. So it's important for me to know what number I'm getting underneath there. So here I have a -2 squared, which is 4, and then minus, and then 4 times 1 times 5 is 20. So 4 minus 20 gives me a -16. So that's what's going to go underneath my radical, all over 2. And now I need to simplify this. So I'm going to have 2 plus or minus, and then my square root of negative 16 is really the square root of 16, which is 4, and the square root of negative 1, which is I, all over 2. And now I'm going to reduce. So what happens here when I reduce is that every number that I have in my fraction is divisible by 2. So I can reduce these and this one. Now you can't do this reduction unless all of the numbers are able to be reduced by the same number. If they're not, then you can't do that. You can't just do 2 of the numbers. All 3 numbers have to be able to be reduced by that common factor. So what we end up with after we do this reduction is we end up with 1 plus 2i and 1 minus 2i. So you probably recognize this problem because it was on your last test. So hopefully you will be able to do this again on the next test. It'll be a different equation, of course, but you should be able to do the same process. Okay, in the next problem, A and B, 5a and b, we're going to find the value for this I, this imaginary number, raised to a really high power. So remember, the trick that we use to find this is to take the exponent and divide by 4. Okay, so when I take the exponent 105 and I divide by 4, I get 26.25. And what I want to look at is the decimal. If my decimal is 0.25, that means I have the same thing as I, just I. If I had a 0.5, I would have an I squared, which would be negative 1. And if I had a 0.75, that would be I to the third power, or negative I. And then if I had a 0.00, that would be the same thing as I to the fourth power, which is 1. So that table will be given to you on the test, so you'll have it to refer back to when doing these problems, but these are pretty easy to do. 105 divided by 4 gives me 26.25. 0.25 means that my I value is just I. I to the 105 equals I. Okay, what about this one, 76? I to the 76. Well, 76 divided by 4 is an even 19. So 19.00. This means I don't have any remainder. That means that my I to the 76 power is going to equal 1. Okay, so for problem number 6, we have a graph that we have to analyze. And the first question is, what do the real zeros of f appear to be? Well, the first place where the graph crosses the x-axis, which is where the zeros are, it appears to be at negative 1, 0. So I'm going to write that down, negative 1, 0. Then it crosses again, or it hits the x-axis again at 0, but it bounces back. So because we have this bounce going on, we actually have a multiplicity of 2 right there. So a multiplicity of 1 at the negative 1, 0. We have a multiplicity of 2 at the 0, 0. And then we have another 0 at 2, 0 with a multiplicity of 1. So that's our next question. Tell whether the multiplicity of the graph is even or odd. Well, we have a graph that is going down, down, down. So if your graph is going the same direction on the ends, then that is an even graph. So this graph is an even graph. We can also tell because our multiplicity is an even number. We have a 1, a 2, and a 1. 1 plus 2 plus 1 is 4. So this multiplicity here is a 1. this one's a 2, and this one's a 1. So the degree of our polynomial for this graph is to the 4th degree. 1, 2, 3, 4, which means that we have an even graph with the end behavior being that they're going the same direction. Okay, so I've just drawn a quick sketch here of what an even graph would look like. Even graphs have the ends going the same direction. So you might have an even positive graph, which is what this one is. Or you might have an even negative graph, which is what this one is. The other two on the bottom are odd graphs. So the first one's an odd positive, and the second one's an odd negative. So those are the 4 different kinds of end behaviors we could possibly get. So just make sure that when you're looking at the end behaviors, you're very careful about which one you're picking. All right, in question 7, it's asking to identify the maximum number of turning points and the maximum number of real roots. Okay, so the thing we're going to look at here is this first term. We want to look at this first term. It doesn't really matter what else is going on with this polynomial to answer these 2 questions. We just want to know what's going on with this first term. First of all, we look up here to the degree, and the degree tells us how many real roots we're going to have. So in this case, we're going to have 6 real roots. And the turning points of our graph are going to be 6 minus 1. It's always 1 less than the number of roots we have. So look at the exponent, get the number of real roots, and then go ahead and subtract 1 from that, and that will give you the turning points. And that's all you have to do for this problem. All right, the next problem, it talks about the remainder theorem. For some reason on the last test, some of you got remainder theorem confused with synthetic division. I'm not sure how that happened. The remainder theorem simply states that you set x minus 2, the divisor, equal to 0, and solve for x. And this value for 2 is what you're going to plug into your function to determine whether or not this particular factor, x minus 2, is a factor for this polynomial. So we're going to go ahead and plug the we're going to go ahead and plug the positive 2 in and then see what happens. All right, so we plugged in the 2 for everywhere there is an x, and we solved and we got that our value for y is -4. This is not 0. So since this value we get is not 0, then x minus 2 is not a factor for this polynomial. So if we had gotten a 0 here, then it would be a factor. For question 9, we're going to use long division to find the quotient when dividing. This problem should look very familiar to you. It was the same problem we had on the last review. All right, so I'm just going to go over this one very quickly because we've already done this one before. So 3x goes into 3x squared x times 3x is 3x squared. X times 6 is 6x. Then we subtract. Make sure you put these parentheses before you subtract. These should drop out. We get -18x minus 6, which gives us a -24x. Then we do it again. 3x goes into -24x, -8 times. -8 times 3x is -24x. And -8 times 6 is a -48. Then you're going to put your brackets around put your parentheses around your subtraction again. We're going to subtract the -24x, and the -24x cancel out. And then we have a -46 plus 48, which is going to give us 2. 2 is going to be our remainder. So we put the remainder over the divisor, 2 over 3x plus 6. And that's it. That would be your final answer with a remainder of 2 over 3x plus 6. Now in question 10, we're going to use synthetic division. And in synthetic division, we have to create a fairly large box. And we're going to do this in rows. But the first thing I want you to do, and I didn't see a lot of you do this on the last test, so I'm going to emphasize it again. We're going to set our x minus 5 equal to 0. And we're going to solve for x. This is the number that you're going to use in your division problem when you're working. We're then going to create a box. And in the top row of our box, we're going to put all of the coefficients that are in front of our x's. So this first coefficient is 1, and then we have a negative 1, and then a negative 19, a negative 3, and another negative 19. Now you should recognize this problem too, because this is the same problem we had on the last review. Now we're going to use positive 5, not negative 5. I know there's a negative 5 right here, x minus 5, but this is our divisor. And so in order to use this 0, we need to set this equal to 0 and solve for x. So that means that the number I'm actually using for my division is a positive 5. Then we start our algorithm. The first thing you need to do is drop down this 1. That's the first thing that needs to happen. And then we start our algorithm. 5 times 1 is 5, and then add. Some of you had a little bit of trouble with this. Negative 1 plus 5 is 4. Then we multiply again. 5 times 4 is 20. Put that right here, and then add. Negative 9 plus 20 is 1. Then we multiply again. 5 times 1 is 5. And then add. Negative 3 plus 5 is 2. Multiply one more time. 5 times 2 is 10. Add. And we get a final negative 9. Now we have all the coefficients for our quotient. And so what you need to do is make sure that you're using the right power, the right degree for this answer. So since we started with an x to the 4th power, we've already divided this by 1 of x, this x right here. So because we divided this by x, that means that our quotient's going to have x to the 3rd as the first term. So just don't forget that. So the next term is the first term down here is going to be x to the 3rd. So I'm going to put that down. X to the 3rd, and then this is a positive 4, so plus 4x squared plus, now this next one's going to be just 1x, and then my constant, which is a 2. Now I have a remainder of negative 9. I'm going to write that as negative 9 divided by our original divisor, which was x minus 5. And that is your final answer. All right, number 11 asks, what is the standard form of f of x equals x minus 4 squared minus 7? This is a quadratic equation, and what they're asking us to do is they're asking us to take it from vertex form, which is what it's in right now, and put it in standard form. And standard form looks like this. ax squared plus bx plus c. So we want it to look like this when we're finished. So what we have to do is we have to take this binomial and we have to break it into its 2 parts, because this is actually x minus 4 times itself. So x minus 4 times x minus 4. We're going to do that first. At the end, we're going to subtract 7. The next thing we need to do is we need to FOIL the x minus 4 times x minus 4. All right, so I FOILed this, and I got x squared minus 4x plus 16. And then I still have this minus 7 on the end. I'm going to combine like terms. So x squared minus 8x plus 16 minus 7. I'm going to combine like terms here. X squared minus 8x plus 9 is going to be my quadratic in standard form. All right, one last problem. Now, this says express the following in standard form. So standard form is going to be a complex number in the end when we get finished. So what I want to do is I want to make sure that I get this I value that's in the denominator. I don't want to have any i's in the denominator. An I represents the square root of -1. And I don't want any square roots or roots in my denominator. So what I'm going to do is I'm going to rationalize this denominator. I'm going to take this value right here and I'm going to turn that into a real number. And the way that I'm going to do that is I'm going to multiply this expression right here that's a complex number by its conjugate. Conjugate just means that this middle sign right here is going to change to negative. Don't worry about this sign. That's going to stay a negative. But this sign in here, when you do complex conjugate, this is the sign that needs to change. So if this is a plus in the denominator to start with, then its conjugate in the middle is going to be a negative. And let me show you what that looks like. Okay, so this is a -1 minus 2i. So some of you got confused on this on the test and you put a plus here and you changed this sign to positive. So that's not what you're supposed to do. It's the middle. It's if this says 1 plus 2i, this one needs to say 1 minus 2i. And it doesn't really matter if this is a positive or negative number. Okay, it's the middle sign that needs to change. Then we're going to multiply the numerator and the denominator by the same expression right here. All right, so I also need to write a -1 minus 2i in the numerator. And now what we're going to do is we're going to FOIL the top and we're going to FOIL the numerators, and then we're going to use a shortcut for the denominator. All right, so I FOILed the top and I got a -4 times the -1 is a +4. A -4 times the -2i is a +8i. -3 times a -1 is a +3i. And then a -3i times a -2i is a +6i squared. All over, and then here's the shortcut. When you multiply a complex number by its conjugate, all you have to do is take the value for a, which in this case is a -1, and square it. So -1 squared is 1. And then you take the square of this value here for b, and you square it. So 2 squared is 4. You add the 1 with the 4, that gives you 5. This shortcut always works when you're multiplying a complex number times its conjugate. It's always going to be the square of a plus the square of b. That's what's going to happen in the denominator. All right, so now what we're going to do is just finish combining like terms. Don't forget that this 6i squared is going to change into a -6 because I squared is the same thing as a -1. So +6 times a -1 is going to give me a -6. All right, so what we end up with is 4 minus 6 plus 11i over 5. And I went ahead and simplified this to -2 plus 11i, all divided by 5. And then we can split this fraction up into two parts. Its real part and its imaginary part. So we get -2/5 plus 11i over 5. And that's our final answer. So I wish you a lot of luck, Longhorns, on this test. I hope that all of you get hundreds, and I hope that everybody passes this 6 weeks.